A 20 kilogram box rests on a table. What is the weight of the box and the normal force acting on it? Now, a 10 kilogram box is placed on top of the 20 kilogram box. Determine the normal force that the table exerts on the 20 kilogram box and the normal force that the 20 kilogram box exerts on the 10 kilogram box. So lots of stuff going on, but basically if you draw it, it's not too bad. So for the first part, we just want to know what the weight of the box is, which is another word for force of gravity. We don't use weight in this class, just force caused by gravity. So let me draw a box in here. So if we have a 20 kilogram box that's sitting here, you guys already know this. If it's at rest, the forces are in balance. So you have a downward force caused by gravity, and that's just going to be 200. It's 9.8 times that number, but I just use 10 because I'm lazy. And if the forces are in balance, then you know that the normal force on this box is 200. Hopefully no problems there. Piece of cake for the first one. But now it gets a little bit more interesting when we toss a 10 kilogram box on top of it. So let's give that a try. So for the second part, whoops. You've got the 20 kilogram, and then there's a 10 kilogram box on top of it. And we want to know two things. We want to know the normal force that this floor is exerting up on both of them, and the normal force that this one has to exert up to hold the 10. All right, so if we look at the floor, the easiest way to see it is, what difference would it make if this whole thing were just one stupid 30 kilogram object? Could the floor really tell the difference? It couldn't. So for the force diagram for the floor, there's a downward force caused by gravity equal to 300, because it's just 10 times 30, which means the normal force from the floor is going to be 300. Now, it's a little bit different, though, and I'll use a different color. We use red for the force that this box has to exert up on that one. Well, for this box's perspective, it only has to support the 10 kilogram box. So if we draw a force diagram at this point, then for that one, we have a downward force caused by gravity of 100 newtons, which means if you're standing here, you only have to hold up with 100 for your normal force. Now, don't get your forces confused here. If we look at the forces acting on the 20 kilogram box, there's a little bit of stuff going on. It's pushing up with 10 newtons on this one, so that one's pulling down on it with 10 newtons. So if we just look at the forces acting on this box, right, there's a downward force caused by gravity of 200. There's an upward normal force of 300, and there's a downward force coming from this box of 100. So everything is still A-OK. This box has a net force of 0, and this box has a net force of 0. It's just, in order to accomplish it for the bottom box, we had 3 forces at work instead of 2. Not a big deal. See you on the next problem.